When we look out into the cosmos, we are often met with a spectacle of light, stretching endlessly in every direction. Galaxies, each containing an untold number of stars, drifting silently through space. Far off distant nebulae, great clouds of gas and dust scattered across the void, forming the building blocks of future worlds. And countless stars, each one home to entire planets, moons, and celestial bodies, all orbiting in their own domain. It's hard not to feel a sense of awe at the sheer scale and beauty of these distant worlds, a reminder of how vast and intricate the universe truly is. But beyond this beauty lies an unsettling realization that what we perceive as the vastness of space is merely the surface of something far larger than we could possibly even comprehend. Even the most powerful telescopes, capable of peering billions of light years into deep space, can only capture a fraction of what's really out there. The universe is filled with places and phenomena we may never fully understand, all accelerating away from us at a pace so fast that their light will never reach us. Despite how much we've mapped and studied, the universe remains largely unknown. For every galaxy, star, or cluster we can see, there are countless more beyond our reach. For all its brilliant sights and staggering scale, the universe is defined just as much by its emptiness. Most of space is a vast, silent void, stretching so far that entire galaxies drift for eternity without ever crossing paths. The distance between stars so immense that by the time their light reaches us, many have already burnt out millions of years ago. Even the largest cosmic structures are surrounded by an unfathomable nothingness. Their existence, a brief flicker in an ocean of darkness. To survive even brief encounters with the hostile conditions of deep space, we've engineered spacecrafts and spacesuits with unprecedented precision, each crafted to withstand extremes of radiation, temperature, and the vacuum of space, enabling humanity to venture deeper into this unforgiving darkness. The deeper we stare into the emptiness of space, the more it evokes a primal unease in us, an awareness of how small, isolated, and vulnerable we truly are, surrounded by the endless void, the absolute darkness, and the unknown that awaits. Among the countless lights drifting through our night sky, one is closer than all of the rest. The moon is our closest celestial neighbor, a natural planetary satellite that has been watching over us for all of history. For thousands of years, humans have looked up and seen something familiar staring back, a friendly face etched by craters and valleys, drifting silently across the vast distance. The surface of our moon is covered in craters, hundreds of thousands of them, the result of billions of years of violent impacts. Unlike Earth, which erases its scars through erosion, weather, and tectonic shifts, the moon has no such forces at work. Every collision that has ever struck its surface remains there, permanent and unhealed. Some of these craters stretch for hundreds of kilometers and are viewable with the naked eye from the surface of Earth. Over the millions of years in which our moon has orbited our planet, however, only one side of it was ever visible to us. Due to its locked rotation with our planet, the other half remained hidden, the so-called dark side of the moon. For as familiar as our moon is to us, the question has always been in the back of our minds. What would we see? if it turned? To answer this exact question, the Soviet Luna 3 spacecraft was launched in 1959 with the sole purpose of capturing the first image of the moon's far side. Equipped with an automated camera system, Luna 3 drifted beyond the moon's orbit, turned its lens towards the unseen hemisphere, and snapped a picture. And what it sent back to us was this. A series of grainy, faded images that carried a real eerie and distant feel. The almost ghostly presence of our moon's other half felt less like a scientific discovery and more like a distorted transmission from an unknown world. A place never touched by human eyes, only by the cold gaze of a machine. Following Luna 3, more missions would try and undergo the challenge of capturing this mysterious other half of our moon, each with varying levels of success. A follow-up spacecraft was launched 6 years later, and while it captured images that were of higher quality, they were just as haunting as the ones before, making our moon seem as alien, distant, and unreal as it did the first time. This trend would continue for the next few years, slowly but surely getting clearer and clearer imagery. But it wasn't until 1972, with Apollo 16, that we got our first clear, full-disc, high-quality photo taken by astronauts using a handheld camera. And it wasn't until the late 90s, 40 years from the first picture taken, that we got a fully mapped-out digital mosaic of the far side of the moon in HD quality. It was the first time we ever saw the dark side of our moon as it truly is, a scarred, lifeless world. Its surface battered by billions of years of impacts, eerily familiar, yet ever so different. Just to fully view and understand our own celestial neighbor, it took us decades, multiple missions, countless failures, and the most advanced technology of our time. If something so close to us remained hidden from us for so long, then how much more do we not know about the rest of the universe? What else out there remains unseen? How many things are we yet to discover? How many worlds exist beyond our reach, completely alien, their nature unknowable? And perhaps the biggest question, are we truly alone? For over a century now, we've pointed telescopes and radio dishes into deep space, scanning the sky for any trace of something beyond us, a signal, a pattern, anything that suggests that we are not alone. But space remains silent. This is what scientists call the Great Silence. It's the unsettling fact that, despite the size and age of the universe, we've yet to detect any clear signs that would disprove the fact that we seem to be completely alone in the vast cosmos. No messages, no signals, no evidence that anyone else is out there. There are trillions of planets, countless solar systems, and conditions that could support life. And yet, as far as we can tell, we are alone in this. No matter how far we look, how hard we listen, it seems to be that space is absolutely silent. A possible explanation for this could be that life is simply uncommon, that the conditions needed for intelligence are far more fragile than we assumed. It could also be that we just have not been looking long enough, or that maybe there was something once, but its time has already passed. Maybe something is out there, but it has no means of communicating with us. Or worse, maybe something is out there and it has chosen to remain silent. The vastness of the cosmos means that even if someone did call out, we may not hear them for thousands or millions of years. By then, we'll probably just be a forgotten memory. They say in space, no one can hear you scream. It's not just a saying, it's a fact. Space is silent, not just in what we can detect, but in a literal physical sense. Space is a vacuum so empty that there are no molecules close enough to collide and transfer sound waves. A scream, an explosion, even the collapse of a star. None of it makes a sound. The loudest events in the universe unfold in absolute silence. But this wasn't always the case. What you're hearing now is the primordial sound. It's the first sound ever heard in the entire universe. The sound of the birth of the cosmos. In the universe's first moments, waves of pressure rippled through hot, dense plasma, early cosmic vibrations traveling through tightly packed matter. In those first few moments, there was enough matter close together for sound to travel in space. As the universe expanded and cooled, these waves froze into the cosmic microwave background, the oldest light that we can detect. This primordial sound was incredibly deep, nearly 47 octaves below human hearing. To make it audible, scientists scaled it up by 50 octaves, shifting it into a range we can perceive. And while it is true that in space no one can hear you scream, that doesn't mean that space is absolutely quiet. There are sounds here, just not in the way we know them. The universe hums with electromagnetic waves, plasma oscillations, and radio emissions, signals that do not need air to move. We cannot hear them naturally, but with the right instruments, we can convert them into something audible, revealing the hidden voices of the cosmos. Using similar techniques, we can transform the soundless environment into a choir of sounds, and we can hear the orchestra of our own cosmic neighborhood. We can listen to the eerily beautiful and haunting music of our own solar system. Jupiter is the largest planet in our system and our closest gas giant. Its sounds are a deep rolling resonance, a groaning breath of something vast and unseen. Waves of static rise and fall, pulsing in erratic bursts. Distant storms rage at scales beyond human comprehension. Saturn is the second largest, a gas giant adorned with icy rings. Its sounds are a haunting blend of rushing wind and distant distorted screams. The echoes stretch and fade, swallowed by a deep reverberation. Uranus is a distant ice giant. Veiled in a pale, featureless atmosphere, its sounds are a soft, resonating hum, layered with distant chiming tones and faint echoes rippling through like bells ringing across an empty expanse. So calm, yet so distant. Neptune is the second ice giant in our system, a distant world where supersonic winds roar across an endless storm. Its sounds are a constant rushing wind, broken by strange and warbling tones that rise and fade. Beneath it, a deep metallic grinding echoes through the void, distant and unplaceable, like something shifting in deep space. Pluto, once the 9th planet, now a distant dwarf world at the edge of our solar system. Its sounds are a series of eerie screeching horns, stretched and distorted, mechanical yet otherworldly, like an alien signal lost in the cold, silent void. While space might be dead silent to our ears, it is very much so alive with sound, a screaming choir of electromagnetic waves, solar winds, and planetary signals, all unheard in a vacuum of space. It's a blessing that we can't hear any of it, because if we could, the cosmos would be unbearably loud. Most of the sounds you've heard were recorded by NASA's Voyager 1 and 2 spacecraft. Launched in 1977, these twin probes were designed for a single mission, to explore the outer planets. They took advantage of a rare event, a planetary alignment that happens only once every 176 years. This alignment allowed them to slingshot from one planet to the next, using gravity to propel themselves deeper into the solar system. They pass Jupiter, Saturn, Uranus, and Neptune, capturing close-up images and electromagnetic recordings, giving us our first real glimpses into these distant worlds. There is something deeply unsettling about these raw images, silent, unfiltered glimpses of enormous worlds adrift in the void, celestial bodies held up in absolute darkness. These photos bringing me feelings of cosmic dread, just seeing these alien worlds through the eyes of Voyager. To see these planets not as perfect illustrations or enhanced composites, but as they truly are, vast and indifferent, floating in the blackness of space, the same way Voyager saw them as it drifted past, capturing these frozen moments before continuing into the unknown. I don't know how to explain it, but to me, these are some of the most unnerving images I've ever seen. There's something uncanny about them, as if these images were never meant to be seen, as if we are looking at something we were never supposed to witness. All these planets, just like the trillions of other worlds scattered across the universe, were born to drift, silent, untouched, through an abyss that neither sees nor remembers them. They will exist for billions of years, weathering cosmic storms, eroding under the weight of time, until they too fade into nothingness. They were never meant to be observed, and yet, for a brief moment, Voyager passed by, a lone traveler staring into the void, capturing what no one else ever would. Silent, motionless, so close, yet still impossibly alone. Astrophobia is the fear of outer space and what might lurk within it. Space by nature is antithetical to anything remotely relatable to our lived experience. It strips away everything we've come to know and understand. Our sense of direction, sound, time, and scale. Nothing about it is made for human perception. Astrophobia is a natural human reaction to these unsettling glimpses, as it emerges from the realization that the universe is filled with things beyond our understanding. When you look at images like this, you can feel it. Saturn is 9 times the size of Earth, with a diameter of 74,000 miles or 150,000 kilometers. Images like this give context to these large numbers of scale. They give a sense of just how much bigger a gas giant like Saturn is to its moons. But then you see a photo like this, and you realize that even our giants are nothing but specks of dust in the grand scheme of things. You put even our sun next to it, and it is suddenly dwarfed by our own star, which is 100 times wider. Then you zoom out even more to see the entire solar system. And at this point, we're dealing with scales so large that our units of measurements completely break down. Just past Neptune, at 30 AU, or astronomical units, which is the distance between the Earth and the Sun, you find the Kuiper Belt, a vast ring of icy bodies left as remnants from the formation of our solar system. It is 100 AU from end to end. This is a shadowy region of the solar system. It is home to dwarf planets like Pluto, Makemake, Haumea, and the forgotten Eris. But the solar system doesn't end here. The sun's pull stretches far beyond the planets, reaching its final frontier, the Oort cloud. A vast ancient shell of icy bodies drifting in the darkness, formed billions of years ago from planets that failed to materialize. It marks the true edge of our solar system. Its size is a whopping 200,000 AU from end to end. Voyager 1, which is the fastest spacecraft ever built, will take 300 years just to reach its inner edge, and about 30,000 years to escape it completely. By then, everything we know will be gone, and Voyager will still be drifting, alone, in interstellar space. Beyond the comforts of our home system and neighboring planets lays the great unknown. This far out, the distances are so great that even our astronomical units are of no use, and a much bigger unit of scale is needed instead. And at such great distances, capturing objects in interstellar space means imaging the nearly invisible. Traditional cameras are useless here, Instead, telescopes like Hubble and JWST use infrared, radio, and X-ray light to reveal what the eye cannot see. What you're looking at now is the first image ever taken of another solar system, 310 light years away. A young star, about 27 million years old, located in a Musca constellation. Using a coronagraph, we can even see individual planets orbiting, like TYC-1b and TYC-1c, both enormous gas giants multiple times bigger than our own. This is BHB 2007, a baby binary system still in formation, its gas rings plainly visible. It is a staggering 700 light years away. And this is a pre-main sequence star, a star system being born right in front of our eyes. Being only about 10 million years old, it is a young system. Protoplanets can be seen still forming. It is located 353 light years away. Using the same telescopes, we can capture other objects which are far bigger in scale. These are nebulae, vast celestial clouds of gas and dust stretching across light years. They are remnants of dead stars, while at the same time acting like stellar nurseries where new stars ignite within. Chaotic swirling forms of light and color light up large areas of deep space, but sometimes these nebulae can form strangely precise and unnatural looking formation that leave us questioning our knowledge of them. If we expand our field of view further, we reach the galactic scale. This is the Milky Way galaxy. It's our home, and it's 100,000 light years in diameter. And all around us are other neighboring galaxies, which are all part of our local group, a gravitationally bound collection of over 80 different galaxies. Think of it like our own galactic neighborhood. There's the small Magellanic Cloud, a tiny dwarf galaxy that's only 200 light years away. The Triangulum Galaxy, which is 2.7 million light years away. Andromeda Galaxy, 2.5 million. Sombrero Galaxy, 31 million. Whirlpool Galaxy, 23 million. Pinwheel Galaxy, 21 million. And one of the largest galaxies containing several trillion stars, Messier 87, 54 million light years away. Home to M87, a supermassive black hole at its center that's 6.5 billion times the mass of our Sun. It is also the first black hole ever to be photographed. Galaxies do not exist in isolation. They form clusters, which themselves are part of even greater cosmic structures. We, for example, exist in a Virgo supercluster, which is a collection of over 150 galaxies and is 110 million light years across. Virgo belongs to a bigger supercluster called Laniakea, a massive web of over 100,000 galaxies spanning 500 million light years. But even superclusters are not evenly spread across the universe. Between them exist some of the emptiest places ever discovered. Supervoids are the opposite of a galactic cluster. They are immense empty regions of space where galaxies are scarce or completely absent. One of the largest is the Boötes Void, spanning 330 million light years. It's so large that if the Milky Way were placed at its center, we wouldn't see another galaxy for hundreds of millions of years. And yet, even larger and stranger voids exist, like the KBC Void, one of the largest known. It's nearly 2 billion light years wide, making our own cosmic neighborhood seem eerily empty compared to the denser regions of the universe. Even among the largest superclusters and supervoids, the Hercules Corona Borealis Great Wall dwarfs them all, a 10 billion light year wide expanse of galaxies stretching across a significant portion of the universe. This colossal structure is just one part of the cosmic web, and yet all of this exists within the observable universe itself, a 93 billion light year wide bubble, which is the limit of what we can physically see, set by the speed of light. Beyond the observable universe, beyond everything we can see and measure, the cosmos might continue indefinitely, a universe without an edge, without a center, without any clear limits. And that is perhaps the most unsettling realization of all. No matter how far we look, how much we map and classify, we're just a speck drifting in an incomprehensibly vast expanse. This is the root of astrophobia, the fear of being lost in the endless void, the fear that we are alone. and a fear that will be gone one day and forgotten. Nothing lasts forever. Civilizations fall, species vanish, and planets decay. But the things we create and launch into space will outlast us. Voyager, the same twin crafts who were sent to study the outer planets in our solar system, will outlast us. In fact, Voyager 1 and 2 will become the first human-made objects to escape the solar system and venture into interstellar space. Halfway through their planetary tour, before leaving, Voyager 1 turned back for one final image, a portrait of Earth from 3.7 billion miles away, a pale blue dot, lost in the vastness. With their cameras shut off and their primary mission complete, they enter the long, silent drift into interstellar space. They will drift through the void for over 1 billion years, long after Earth itself has changed beyond recognition. It will outlast our cities, our species, and even our sun. And if something is out there, and they find it, will they understand what it is, who built it, and what kind of world it came from? To answer that exact question, NASA placed a message aboard each Voyager probe, a golden record, a time capsule carrying the story of Earth far beyond the reaches of humanity. But the challenge wasn't just what to say, it was how to make it understandable to something completely unfamiliar to us. Whoever or whatever finds Voyager won't speak our language, won't share our history, might not even perceive reality as we do. So the record's creators had to start with something deeper, something that transcended culture, biology, and even intelligence itself. A message meant to not just be read, but decoded by the unknowable. The cover of the golden record is more than a label. It is a set of instructions designed to be understood by advanced intelligence, no matter how different they are from us. It starts with something fundamental: hydrogen, the most abundant element in the universe. A simple diagram shows the energy transition of hydrogen's two lowest states. This transition emits radio waves at a precise frequency, a constant in physics. This acts as a universal clock, a baseline unit of time. From this, every other measurement, time, distance, frequency, is based on a single fundamental constant. Once this unit is deciphered, the binary code inscribed around a disk can be used to determine its playback speed. This number translates to 5.1 billion, and when multiplied by the hydrogen transition period, which is 0.7 nanoseconds, it equals 3.6 seconds in human time, the exact duration for one full rotation of the record. If played correctly, the first thing to emerge will be voices, greetings in 55 languages.
Konnichiwa, o genki desu ka?
Hola y saludos a todos.
Hello from the children of planet Earth.
Then the sounds of Earth, waves crashing on a shore, wind moving through trees, the calls of animals, familiar sounds, and music. The record also contains 116 images encoded on the other side of the disc as raw signals meant to be reconstructed. The first image is a simple circle, a test to ensure the data is being read correctly. From there, the image is built: human anatomy, scientific principles, human culture, Earth's landscapes, and finally, a view of our planet. Voyager is now so far from Earth that its signals take over 200 hours to reach us. Even as their instruments weaken, they continue to transmit faint signals, drifting farther and farther, each passing second. When the last stars begin to fade, the golden record might still be floating through the void. They will become eternal artifacts of human civilization. The record serves as a monument of existence, of proof that something intelligent once lived, built, and sent this artifact into the void. If Voyager is ever found in a distant future, they might not understand our words, our music, or our images. They might not even be able to decode it. but they will understand that it was made. They will understand it as a signal, a message that says, you are not alone. And while space still holds so many more secrets and mysteries, I think it's best to leave that up for another time. Until then, I'll leave you here, and I'll see you again very soon.